Alright, so this is chapter 6, or chapter 10, section 6, circles and arcs. Our learning objectives is that you will find the measures of central angles and arcs and find the circumference and arc length. The first item I want to point out is what an arc is. So first thing, let me tell you that the central angle is the angle that has a vertice at the center of your circle, central angle. So, for example, if I were to tell you that this central angle, because its vertice is in the center of the circle, is 42, then the arc of that corresponds to that central angle is also 42. And we show, so when we're naming an arc, it's like similar to a line segment where we list the two letters that are on the edges of the arc, and then we put a little rainbow over it to show arc. So if my central angle is 42, my arc measure is also 42. So the arc measure and the central angle are always equal. Alright, so in this problem we're just going to name the arcs. So minor arcs are inside a central angle. So I think of it as minor is less than 180 and major is more than 180. So all of our minor arcs of circle O, the first one we can look at is AOD. AOD, you can see it's a small one, like a minor. So AD is a minor arc of O. COE, COE is the one that's vertical to AOD. And so CE is a minor arc. So let me mark that CE. And AOC is a central angle. So that's AOC. So that's from here around the circle to here. Still a minor arc. Okay, and then DOE. So that's DOE. And those are the minor arcs. Semicircles are what the end result when we have an arc along the diameter. So if you look, AE is the diameter, or AE is a diameter. So ACE and EDA are both semicircles. Okay. And then major arcs. So the major ones are, let me pull this down here so we can see. Sure. So the major arcs are the ones that are bigger than 180. So ACD, AC, and all the way around to D is a major arc. CEA, CEA is a major arc. EDC And then especially with major arcs, we have to make sure that we are doing 3 points on our circle. EDC, and then DAE. Boom. So all the big ones are major, and they're pretty easy to remember. Minor, less than 180. Semicircles are the 180, and I believe, hold on just a second. No, it didn't include the, if CD were the, you could also write CD is the diameter, so CAD is a semicircle. Okay, so using the property that central angles are equal to the arc lengths, we are going to find the measures of each item. So when we look, we want to find the measure of arc BC. That's this guy right here. His central angle is 32, so his arc measure is 32. We want to find the measure of BD. That's this guy. If you look, the 2 angles that make the central angle for BD are 32 and 58. And if I add those together, we get 90. So this combined central angle is 90, so our arc measure is also going to be 90. What is the measure of ABC? If you look, that is on a semicircle. So semicircle is for half of a circle, straight line, 180 degrees. Okay, lastly, what is the measure of AB? So ABC was 180. AB, we don't know. And BC is 32. So essentially, measure of AB is 180 minus 32. Go to 7, and that's a 2, and that's 8. 7 minus 3 is 4. 148? Question mark? Check my math. Okay. All right, so now let's get complicated. We have this problem. A film, 2 foot wide circular track, a 2 foot wide circular track, 2 feet here, for a camera dolly set up for a movie. Excuse me, picture. The 2 rails of the track form concentric circles. That just means they have the same center. They just have different radii. The radius of the inner circle is 8 feet. And how much farther does the wheel on the outer rail travel than a wheel on the inner rail of the track in 1 turn? So we're going around once. So the first thing that we need to do is create an aerial view. So here is our inner track, it's 8 feet. And here is our outer track, it's 2 more feet. So we are going to find the circumference of the inner circle. Okay, so the first thing that we're going to do is find the circumference, because our little camera is riding around the track. So we're talking about circumference, we're not talking about area. Circumference of a circle is 2 pi r. Make sure we write that formula down because we're using it. We are going to put in a radius of 8 for r, and then simplify it. So that is equal to 16 pi. All right, so that's how far around we go with 1 on the inner loop. So now we need to find the circumference of the outer loop. We're going to use the same formula, except we need to find the radius of the outer loop. He is 8 feet plus 2 more feet, which is 10 feet. So the radius of the outer loop is 10 feet. Alright, so we're going to use our same 2 pi r. We are going to put in 10 for r, and then we simplify it to 20 pi. Okay, so now we find the differences of the two circumference because it says how much farther does a wheel on the outer rail travel than the wheel on the inner rail. So we're going to go 20 pi minus 16 pi, which 20 minus 16 is 4, and the pi gets to stay just like a variable x. And then we're going to use a calculator. So if I'm using my calculator, let me show you how I would do that. I would go 4 times pi equals 12.56. And so a wheel on the outer edge of the track travels about 13 feet farther than a wheel on the inner edge of the track. All right, so now we're going to take a look at arc lengths, because all an arc length is a portion of your circle. So because we're taking a portion of the circle, that should cue you in. I'm always going to use a fraction. So the way I remember the formula is that it's your arc length divided by 360. So the angle that you're at divided by 360, because there's 360 degrees altogether. So it's the fraction of the circle you're looking at times pi times the diameter. And the reason we use diameter in this case, please recall that diameter is 2 times the radius. We use these interchangeably. In this case, I have the diameter, so I'm using diameter in my formula. If you want to convert it to radius and use 2 times radius, that's also okay. So I take my formula. I'm going to substitute in 90 for my arc length and 16 for my diameter. We use 90 because our central angle is 90, so our arc length is also 90. So 90 divided by 360 is 1/4. 1/4 times 16 is 4, and the pi gets to hang on. You always want to stick with pi unless they ask for an approximate or a round to the nearest. Otherwise, leave it in terms of pi. All right, we're going to do the same thing. What is the length of the arc shown in red? And if you look, we've got this major arc here. His arc measure is 240 and his radius is 15. So when we go to our formula, the measure of our major arc divided by 360. In this case, we're going to use 2 times r because we have the radius. We substitute in 240 for our arc length divided by 360, and we put in 15 for r. 240 divided by 360, well, 24 over 36 is, if you divide both sides by 120, top and bottom by 120, gives you 2/3. Let's do that. 12 goes into 24 twice. 12 goes into 36, 3. I'm going to shimmy shuffle these around a little bit. I'm going to combine the 2's together. I'm going to put the 15 right next to the 4. And I'm going to put the 3 over the 15 because What is 15 divided by 3? 5. And then 4 times 5 is 20, and 20 pi is our final answer.